Hi, welcome to the episode 0 of the new series Gravitation Unveiled. I'm Mohammad Reza Sapur and I'm a third year math undergrad in University of Tehran. And we are going to learn about gravity in this series. The reason I'm doing this is because I always was interested in physics and the relation to mathematics. And also I'm doing a minor in physics. And my professor is organizing a workshop on this matter. So I thought that it would be a cool idea to make videos about it and continue making videos about mathematics of the subject, especially since I'm not that good at the physics of the subject, but I try to learn about them and just come here and make it simpler for other people to understand. And as I said, I'm not a professor or an expert in this subject. I don't know if that's a advantage or it's a negative point, because in this way the both of us are in the same level, and I may go through some difficulties, and I will explain them to you. So here's the plan. And I'm just going through the phase 1 for now because I don't know how much consistency I will have through this project. It's a really long project, as you can see. I think this is going to take about 6 or 7 months, maybe less, maybe more. But here we go. So in phase 1, we're going to learn about the foundations of relativity and mathematics of the subject. So in the first chapter, I'm going to some topology mostly. Topology is not directly useful in gravitation, but to understand about manifolds, you need to know some topology, and I think we are going to do 7-8 videos on the matter, but nothing much. Then we have smooth manifolds, and I'm going to teach that from Lee's book, Introduction to Smooth Manifolds. And then we're going to read MTW's chapter 1, and that's the book I'm talking about. It's a really famous book. And some people, it's the Bible of gravity. Then we are going through Newtonian physics and vector calculus. I don't know exactly how this applies in relativity, but I have heard that you need to know this subject, Newtonian physics, to understand gravity. So we're going to learn about some vector fields and differentiation, some integral theorems such as Stokes' theorem, and then we are going to read some chapters of Goldstein's classical mechanics. Then we are going to do some linear algebra and learn about special relativity, since we are working with Minkowski's meter, and if we know some linear algebra, that will help our understanding of the matter. And of course, we are going to read some chapters of Taylor and Wheeler's spacetime physics, and then we are going to learn about some vector calculus and Maxwell's equation. That will be MTW's chapter 3 and 4, and Griffith's introduction to electrodynamics. Griffith's box, actually, first few chapters, I think it's purely mathematics, and that will do the job. Then we are going through some tensor analysis, and we are going to do again, this book that is written by Lee, Riemannian Manifolds, and Spivak's Advanced Calculus. You're going to learn about tensor algebra and Lie algebra, differential forms, and such things. Then we have chapter 6 and 7 of MTW's book, and we are going to learn about some hyperbolic geometry and the symmetries of space-time. For hyperbolic geometry, I haven't figured out what source I'm going to use, but I think mathematics for physics students, there's a book that a chapter is specified to this subject. And then we have Introduction to Differential Geometry and Manifolds. This is purely mathematic subject, and we are going to do again Smooth Manifolds by Lee, I guess. And that's it. I hope we continue making videos about the subject and have consistency. I hope you support me in this matter and come along with me to this gravitation journey.